I want to thank everybody for being here. Again, about 25 people that join us or that are joining us. It's the holidays. We're in the middle of a pandemic. And again, just a lot of things going on. I know things are moving fast. So I really appreciate you all taking the time. Anybody that knows me and knows All Things Open, if you've attended any of our things before, we might thank you to death. We generally start that way. We thank you profusely and 10,000 times because, you know, we understand there are a lot of places that you could be and a lot of things going on. So we never take your participation and attendance for granted. And I mean that sincerely. So thank you truly and sincerely. For those of you that were not able to make All Things Open and attend and participate, no problem at all. Let me give you a really quick update, if that's okay. Here's what I'm going to do. I'm going to let's see, share my screen, and I'm going to share mine. And I just want to give you a really quick update. I would say the majority of people on this session, on this call, have received our post-event updates via email, and where you've seen something come across via social media. So I know I'm risking repeating information that you're already aware of, but I do just want to let you know. So ATO 2020, this was our first virtual event, all virtual. That wasn't preferable for us, frankly. We love in-person events. That's what we enjoy. That's what we've been doing now for almost 15 years or thereabouts. So that was our preference, but we just weren't able to pull it off this year. Ultimately, we're most concerned with attendee safety. And this year, obviously, we just couldn't risk that. So we did decide to make the event 100% virtual. All things considered, we felt it went extremely well. So again, you can kind of see my screen. You may or may not have seen this blog post, but it really was an incredible year in so many ways. It was because, again, it was virtual, and we were planning and coordinating at the same time that the pandemic was evolving, which made it super interesting. We were working with speakers that were dealing with having to work from home, and kids, and everything that they're dealing with and they were dealing with. We were working with sponsors that had never worked with a virtual platform before. So that was really interesting too. There was a lot of training that was required, and really, I won't say hand holding, and I don't mean that in a negative way at all, but really kind of taking them through the process and explaining some things on both sides, on the speaker side and on the sponsorship side, and even on the attendee side. We did lots of training sessions and things like that. It was just a different year. It was new for everybody. But after all was said and done, the numbers were really great. There were a lot of virtual events that we were competing with, just a lot of things going on. It's not easy to do events, so we respect everybody that does them. But a lot of them were very close to us. A lot of them were even during the same week. So all things considered, to have about 7,500 people that registered and joined us worldwide from all over the world, this was very much a global event as well, right? So this was far more international. It had more of an international flavor than it ever had before, but about 7,500 people registered. Most everybody participated and logged on at least for one session over the 2 days. More than 75 countries. Actually, I think we ended up right at about 100 countries throughout the world actually registered, which we felt was great. You can see the attendee breakdown, the number of sessions and number of speakers, and the number of companies that participated. Again, we were really pleased and just very, very grateful, all things considered. It was an unusual year, but it turned out to be really great. The general feedback that we've received has been very positive. We always distribute a post-event survey and ask for feedback after the event, and we ask for honest feedback. It's an anonymous survey, and we do that on purpose, right? We want people to be honest and provide constructive criticism and let us know how we can do the event better. So I can promise you that we always review those post-event surveys, and this year was no different, and next year's event will be better because of that. So if you submitted feedback or provided any just guidance or suggestions or your opinion on how we could do it better, thank you. We really do appreciate that. And again, we actually read your comments, and we do every year. We pour over those things and take those into consideration as we're planning the next year's event. I do want to let you know that save the date. We do have. I'm just going to show you this. So save the date for 2021. So please put these dates on your calendar, the 17th through the 19th. That's Sunday through Tuesday. That's next October. So that's, gosh, we're already 10 and a half months away. Hard to believe, but that's it. So we've already started planning. We're already taking steps. I think right now we're planning on a hybrid format, meaning in-person and virtual, having an in-person and virtual element to the conference. We think that by next October, this is just our opinion, Lord only knows how this thing is going to kind of roll out and actually work. There are just so many variables at play right now, but we think that Q1 and Q2 of 2021, hopefully the vaccine will be, distributed and it go first to a targeted audience, but then, will be rolled out in a more general way to everyone. And we hope that takes place quickly, but we think Q1 and Q2 of 2021, there's still going to be some delays, still some issues for sure. But then beginning with Q3, we think that, things are going to start to improve. And then hopefully by Q4 of 2021, October, November, December, that general time frame, we hope that things will be on, back on a path to recovery, so to speak. So we do anticipate there being an in-person element to All Things Open 2021, but we're going to still do the virtual, right? We'll still live stream a lot of our content in a way that we've never really done before. So please put it on your calendar. The eventual or the final format is to be determined, of course, but we would love for you to join. And in this blog post on our website, you can actually save the date right there and add that to your calendar. It does that automatically. I do want to let you know about, let's see, Spacewalk. We did this for the first time last year. If you go to our Meetup page, and I know in our last email, we came out with some spacewalk information, but this is our one program of the year. We actually start every year with this. We did it for the first time last year, and it was super successful. Last year was in person. We had about 300 people there that joined us in Durham, North Carolina at the Carolina Theater. It was a lot of fun. We made some pretty major announcements, and we'll do so this year as well. But this year it's Tuesday, January 19th. As of right now, that's a virtual event. We might do something on location, but live stream it from the theater, but it'll just be us and a few other people, but be on the lookout for that. And if you add that to your calendar, that would be great. We are going to do a giveaway today. Here, I'm going to actually stop sharing my screen now. Okay, so we are going to do a giveaway today. I put over in the chat stream the link. You can take a look over there. There aren't that many comments yet over in the chat stream, so it's not, so far up or so far down that you've got to scroll for it. But you can actually just click on that. We've actually put together a WooFoo form. The giveaways that we're going to do this time after this meetup, we're going to give away some Raspberry Pi desktop kits. We've got multiple versions of the Raspberry Pi desktop kit. We're going to give those away. We're going to do some t-shirts. We're going to do some hats. I'm not wearing a hat today. Normally I do, just to kind of show everybody what it looks like. Those of you that don't know, I'll show you that right there. It's actually a pretty cool hat. I'm biased, but it really is. Very, very popular. We're going to give away some of those. And we're going to give away, for those of you that might be familiar with it, Donald Knuth's The Art of Computer Programming 4-book series. So if you're a programmer, this would be a great, series of books. It's actually comes in a really nice case to add to your bookshelf. It's about a $200 or $250 value. We're definitely going to give that away. So if you're interested, let us know via the WooFoo form, and we'll just pick winners on a first come, first serve basis. We think that that's about the fairest way to do it. So let's see. Sam, thank you for being with us today. I truly appreciate it. Folks, let me preview or kind of establish the context as to why we really like this talk and why we chose it. And again, Clearview and Sam is why you're really here, right? So I moved as quickly with my intro as possible. I know you didn't sign up, you didn't register, you're not joining us to hear me talk. But Sam, Clearview, privacy is a big deal for us and to us, and it has been for a long time. Clearview really caught our attention. I know it's caught the attention of a lot of people. There have been multiple articles written about it. The New York Times, Vox, etc. A lot of media outlets have covered Clearview, and it's something that I've certainly been reading about for, again, a good period of time, just kind of keeping an eye on. Basically, primary reasoning for me is just the way it works, right? It's scraping data from the internet, it's facial recognition, it's some things like that. So ultimately, we sort of are taking and have taken kind of a white hat hacker approach to this. We kind of want to kind of maybe open it up and explain some of the details from an awareness perspective or for the purpose of awareness. We want people to be aware of it. And it's just something, you know, we feel like people really need to be aware of. And I know you're going to implement or utilize some open source technology to sort of demonstrate the way Clearview works. So there's that, certainly that open source element to this presentation. And this is one, you were initially scheduled to deliver this at ATO. Weren't able to do that, but now we were just so grateful, and we really appreciate your willingness to kind of circle back around and deliver it at this meetup. And we felt like it was worthy of kind of a standalone presentation, right? There's no competition from other tracks or other sessions going on at the same time. But this being standalone, we definitely wanted to kind of give you this platform to do this presentation and to kind of get the word out, and then to engage in dialogue with our audience, with our community. Because again, the nature of the project, the nature of the platform is just one, again, that sort of caught our attention, and we thought that it was worthy of that. So I really do appreciate you joining us today. I've seen the slides, and so I know what's coming. I know this is a really good presentation, and I know you're going to do a great job. Regarding one thing that I will say just before I turn the microphone and the screen over to you is Q&A. And Sam, I know we talked about this a little bit before the meeting or today's session. You know, I think what you prefer to do, given the structure of the presentation, the structure of the slides, is to go ahead and run through the presentation and then do Q&A at the end. I know that some speakers choose to kind of break it up. They'll do half and half, or maybe a third, and take questions. You know, they'll kind of insert questions within the presentation. Just given the nature of this and the need to establish sort of the entire story, the entire context, I think you're going to roll through the presentation in its entirety, and then we'll handle the Q&A toward the end of the presentation. So I just wanted to kind of set that expectation with everybody that's live today. And also, because this is a Zoom webinar, those of you that have done Zoom webinars before, you know kind of how this works. At the bottom of your screen, you're seeing 3 icons or 3 options. You're seeing chat, and then you're seeing Q&A, and then you're seeing raise your hand. So from a Q&A or a question perspective, you can pose your questions over in the chat stream. I will tell you that if you do that, you run the risk of it maybe being lost a little bit, because there are going to be some comments that kind of pile up. But also, probably the best way would be just be the Q&A feature. You can click on the Q&A and then you know, input your question there, and then, you know, you can hit click submit, and then that will show up, and then we'll address those once Sam has wrapped up the talk. And then there's also the raise your hand feature as well. So raise your hand is, if you want to sort of raise your hand, Sam at the end of the presentation can choose to recognize you, and then we can activate your microphone. And it's a good way to bring people in live and encourage that sort of live dialogue via audio. So that's really what that is. So those are the 3 icons, or the 3 options that you're seeing there at the bottom of your screen. So again, I just wanted to kind of get that out of the way, because we generally have that question from attendees is like, okay, so if I have a question, should I just pose it? What should I do? Or should I save it till the end? So we always try to address that as we get started. We found that's the most effective way. So again, during the presentation, if you have a question, go ahead and submit it. And then once Sam wraps up the presentation, we'll address those toward the end as we maybe 40 minutes in or thereabouts. Sam, thank you again. I'm going to go ahead and turn it over to you. And here's what I'll do. I will deactivate or turn off my video and my audio. So that way, again, the floor is yours. And then if you want to start sharing your screen, you can. And I know that your microphone is working and you can roll right into your presentation. But thank you for being with us today.
Thank you, Todd.
You bet.
I'm going to go ahead and start sharing my screen. And I'm hoping you can see everything okay.
Yes.
Awesome. So the New York Times was the first to publish an in-depth report about Clearview AI, a company that has collected billions of personal images from the internet and is now using those images right now to give law enforcement agencies, corporations, and even foreign governments the ability to track and identify virtually anyone. Whereas most articles have focused primarily on what Clearview has collected and who has been using the app, I'll be focusing on how Clearview's deep learning technology works, by demonstrating how you'd piece together a similar system using off-the-shelf free and open source tools. My name is Sam Brice, and I'm a software engineer at 2 Sigma Investments in New York City, and I work within a company's AI and machine learning modeling engineering team. I'm here to demystify Clearview AI by walking you through the underlying technology behind its facial recognition, and in the process, explore some defenses to the privacy problems engendered by Clearview, By the end of this presentation, you will understand all the tools behind Clearview AI, and you'll hopefully also appreciate why we don't need another Clearview. First, we'll start with a short history of facial recognition. Then we'll dive directly into the deep learning development lifecycle, from collecting data to choosing the right model for object detection, to tracking a vehicle using deep learning or EID models, to ultimately designing and deploying a deep learning application. Once we've established a more concrete understanding of the process, we'll talk about how you can go ahead and protect your privacy from facial recognition technology using tools such as adversarial glasses and laws such as the CCPA. Finally, we'll end by reflecting on the high-level privacy implications of facial recognition technology on society and why this is indeed an important conversation to be had. Facial recognition in the US dates back to the 1960s, when mathematician and computer scientist Woodrow Bledsoe piqued the interest of the CIA with his research in artificial intelligence. Back then, much of the work was manual, and researchers were limited to extremely small data sets. Although the technology proved vastly superior to humans, it wasn't until the advent of the World Wide Web, along with technologies such as Google and Facebook, that we see a radical expansion of its commercial application. By 2008, Google was processing upwards of 8 billion searches a year, and Facebook had connected over 150 million users worldwide. The combination of those two platforms and various others on the web effectively overcame the dataset and processing limitation of Woody's earlier work. In 2008, we also learned for the first time details about the FBI's Next Generation Identification Interstate Photo System, NGI-IPS, a system that started with roughly 10 million criminal mugshots from the national database, then eventually grew to include driver's licenses from individuals across various states. Whereas it took the FBI 10 years to grow its database from 10 million to over 640 million images, Clearview reportedly grew its database to 3 billion images practically overnight. That's an alarming number to think about. However, given how Clearview's underlying deep learning technology works, it makes sense. Because as the size of the underlying training dataset grows, a deep learning model's accuracy and performance will continue to improve. Deep learning development can be illustrated as a cycle of steps, starting from data collection to ultimately deploying an app or service to users. There are various means of collecting publicly available data from the web. In Clearview's case, they've already admitted to scrapping images, like Todd talked about earlier, from sites such as Facebook and Instagram. Such a process is as simple as writing a bot to visit the Instagram account of @Instagram and recursively downloading images from each of his 352 million followers. In our case, for the CCTV demo, CCTV traffic camera feeds are made available publicly by the New York City Department of Transportation. The website webcams.nyctmc.org provides real-time traffic information on all 5 NYC boroughs. You can find about 740 cameras listed on the DOT website. Scaling data detection from the DOT API is again as simple as deploying a service in AWS. Once the data is readily available for local processing, the next step is choosing the right deep learning model based on the data available and the desired use case. When it comes to deep learning-based object detection, the 3 primary object detection model types are faster region-based convolutional neural networks, also known as faster RCNNs, you only look once, aka YOLO models, and single-shot detectors, also known as SSDs. Each model type includes trade-offs on complexity, speed, accuracy, and efficiency. Faster RCNNs are the most famous, accurate, and ironically slowest of the 3 model types. YOLO models tend to be the fastest performers, while SSDs strike a balance between faster RCNN and YOLO type models. In choosing the right model for object detection, in addition to quantitative metrics such as speed, accuracy, and efficiency, there exist various qualitative considerations to be made, based, of course, on the nature of the application and on the underlying data. For example, SSDs tend to have issues in detecting objects that are too small or too close. There are optimizations to account for this. And in developing the CCTV demo application, I use the open source library called ImageAI. ImageAI is a great library that greatly simplifies the process of loading and running various types of models. With about 30 lines of code, I was able to load a pre-trained RetinaNet model and easily run object detection on a frame image. As you can see from the results, the image AI pre-trained model was able to successfully detect cars at various distances from the camera. Now, building on this vehicle detection capability, the next step is using an image recognition model to distinguish between different cars. When a deep learning model processes an image, it first converts the image into a numerical format known as a vector embedding. FaceNet most famously introduced vector embedding for face recognition in 2015, where it leveraged a triplet loss function to achieve a record 99.6 accuracy on the learning faces in a wild data set. For vehicles specifically, similar algorithms and libraries such as VehicleNet and RetNet leverage the same type of triplet loss and vector embedding techniques to enable very efficient vehicle ID and re-ID capability. While single vehicle identification is a challenge parallel to single face identification, the task of a large-scale urban vehicle identification and re-identification encompasses a much broader set of complexities. You can see a hint of those complexity involved by looking here at the map showing the coverage blind spots within the New York City Department of Transportation CCTV network. In addition to incomplete coverage and visibility, there are complicated domain-specific deep learning modeling challenges in large-scale urban vehicle tracking scenarios. Unlike with faces, where there is some underlying expectation of uniqueness, vehicles are generally expected to be identical. Whereas the best means of uniquely identifying a car would be based on the license plate, it's not always an option due to privacy reasons. And of course, with low resolution images, that's not always possible. The 4 best documented methods used in multi-target, multi-camera tracking include attribute recognition and metric learning, detail-aware attentive multi-inference learning, GAN-based learning, and multimodality database frameworks. With our scope in mind and the complexities mentioned earlier, we'll be targeting a subset of Manhattan traffic, specifically along the downtown stretch of FDR Drive. Focusing on traffic along a linear stretch of road enables us to work on implementing the same type of technology as featured in Clearview's desktop and mobile applications. What makes the downtown stretch of FDR Drive ideal for simple identification techniques, similar to what Clearview has likely implemented, is the consistency in camera orientation, illumination, and resolution. Within such a consistent global camera context, a simple identification algorithm would successfully track a vehicle's movement across a parkway, because it requires fewer adjustments for local camera, environmental, and contextual factors. To implement vehicle re-ID for the CCTV demo application, I use a pre-trained DenseNet neural network tuned on the large-scale BenchSet dataset for vehicle re-ID in real urban scenarios. What the DenseNet model does is it extracts vector embeddings for each detected car. We can then use those embeddings to calculate a distance metric to re-identify a specific car. With all those tools at hand, object detection, vector embedding, vehicle re-ID, we're ready to actually design and implement an end-to-end tracking application. So let's start combining those powers. Combining everything we've collected so far, we're going to design and build an end-to-end tracking application. I will be going into a lot more, I go into a lot more detail about this on my blog and on GitHub, but here we're going to be going over some of the sketches from the design process, and I will also explain how decisions made regarding data structures greatly facilitated the development process. As illustrated here in this user interface action flow, the application is centered around camera frames and object detections. With all contextual information regarding an object already included in the object's uniquely identifiable ID, exchanges between the client and the server are very succinct. This brevity keeps the client-server architecture and API lean and straightforward. An additional benefit of the information symmetry between the client and server is the ability to efficiently distribute the identify, re-identify, and match workload across both boundaries. The server is only responsible for sending frames to the client, as well as distance metrics indicating how closely each car within a frame matches the car dynamically selected by the user. The client uses that information along with real-time settings from the user to determine an appropriate match. Because matches can be determined in the client, the tracker settings can be adjusted freely by the user, and the browser would reflect the results immediately. Using pre-processed object detections and pre-computed vector embeddings made a lean stack suitable choice to develop and deploy the application. With their vector embedding stored in a language-agnostic data structure, it was actually possible to use native Node.js to calculate minimal Euclidean distance and effectively run the ranking component of the ReID model without needing to deploy a separate Python environment. To start tracking a vehicle, the user first selects the target vehicle from an initial anchoring frame. The application will generate a vector embedding for the chosen car. Then, that vector embedding to use to identify the vehicle in downstream frames and cameras. For subsequent cameras along the vehicle's expected path, the application will calculate the embedding for all detected vehicles, then compare those embeddings with the initial embedding to again re-identify the target vehicle. By implementing this detection re-identification pattern frame by frame across various cameras, we can effectively track a vehicle's progress along the parkway. This very elementary set of functionality is a building block towards more complex tracking applications. So you're all in luck because you're about to get an exclusive view into the demo source code. I have not actually published this code online because I don't want to, largely because I don't want to explain the Node.js related stuff. But I will actually give you a quick look into exactly what it looks like. I mentioned earlier that I used something called a lean stack to develop the application, and it's an acronym for Linux Express and Angular, something that I created a few years ago, and actually have not updated in a while. And the gist of the stack is the idea of using the same language and the same design patterns on the client as well on the server. This stack is primarily built in TypeScript and dependency injection. And if you look at the source code for the demo itself, you'll see here it's just a very basic Angular app. This is actually built from the Angular CLI template with a few self-explanatory components. And on the server side, likewise, it's a starter template from the Nest framework, which is a TypeScript-based server-side framework. And I only had to implement a very small service to actually get the ReID matching capabilities to the client side. So to run the app, you would navigate to cctv.herokuapp.com. And this is actually running on a free dyno because the data store for this application is not stored within, it's not stored within Heroku. It's not stored within the deployment. It's actually stored offline. And I was able to do that by having the frames and all the computations stored inside GitHub repositories. And by connecting to this data set online, it made it such that I only had to deploy a very thin a very thin layer of code into Heroku, and I didn't have to worry about any kind of resource constraints simply because of the fact that most of the resources were being fed into the application like over the web. If you actually navigate into any one of these data sets, you can actually take a look at the generated vector embeddings, which are actually called features in a lot of instances. And it's just a JSON file with an ND array that was generated by the DenseNet CNet from PyTorch. Now, this application, like I mentioned, is very simple. To start tracking a car, you would effectively go to the starting frame, and you can navigate up and down the timeline at any point to hover over the cars that are being tracked on the camera, select it, and start tracking. So I'm going to open up DevTools just to give you guys an idea of what it actually looks like when the responses are coming back from the server. And likewise, I was able to implement a few things in this client, such as scrolling. Let me go back here. So I like to pick this car largely because, I'll explain in a second, largely because it's slightly easier to work with. As I mentioned in my blog post, I didn't tune this model for the CCTV feeds from New York City, largely because I wanted to kind of demonstrate what you're able to do just by using an off-the-shelf piece of technology. And so a few things that we can talk about later involved optimizations you can make to improve these models. So here I've selected this car. And once I start tracking, you'll see it sends 3 requests to the server. Each of those requests are for these 3 different cameras. And what comes back from the server, I'm not going to go into details to all the entire data set, because a lot of it is metadata that I actually don't use in the front end. What comes back from the server is a bunch of information regarding the matches that it has collected off of these cameras. And the client uses that information, may that be how high of an estimation the server believes the matches are, or if I had additional settings, such as limiting the search or limiting the tracking to a specific time frame, I would be able to get that information from the client and use simply that information on the client to adjust what the client is showing, or to adjust what the client thinks is an appropriate match. And so that's basically it. So with all this data at hand, the vector embeddings, the camera locations, and timing, you can imagine how easy it would be to actually build a Amber Alert type of demo application. So with the Amber Alert application, all you would do is choose a representation of a vehicle that you would like to upload and search for, and the system would use the embeddings that are already calculated to find one that matches, that most closely matches the vehicle that you're looking for. Now, I didn't finish this demo because it wasn't part of this presentation, but if you're interested, I can share the code with you, and I can also guide you towards how you could possibly finish it yourself, or you can just play with it on your own. So back to the Clearview AI and what this technology means for your privacy. All deep learning models are vulnerable to what are called adversarial perturbations. Adversarial perturbations involve changing specific pixels on an image to trick a neural network into believing one thing is something else. The example that we're showing here with the panda is a bit exaggerated because the changes made to the actual panda image look exactly like this. To the human eye, it's pretty much imperceptible, but to a deep learning model, it was very much convinced that what it's looking at is not a panda. To fool real-life facial recognition systems, researchers have developed what are called adversarial glasses. These glasses would enable you to not only impersonate a specific person, but you could also completely evade face detection. Another more practical method you can apply in real life involves the use of infrared light. Because infrared light is able to trick a digital camera into seeing red light as blue light or blue light as green light, using infrared LEDs, such as one hidden in a baseball cap, you can successfully create adversarial perturbations to the digital camera. And in effect, as we mentioned earlier, you can impersonate someone like a specific person, or you can completely evade certain facial recognition systems. While not quite the same as the adversarial glasses, these reflectacles from the creators of Urban Spectacles uses both infrared absorbing lenses in combination with infrared reflective frames to completely blind digital cameras from seeing your face. Since Clearview likely already has very clear pictures of your face, your best bet is a legal recourse. Many of you may be familiar with the GDPR, the European Union's General Data Protection Regulation, which made a big splash a few years ago and had practically everyone online scrambling to make sure they were in compliance. the California Consumer Privacy Act, the CCPA, which came out shortly after, is based on the GDPR. Another similar law you may not be familiar with is the Illinois Biometrics Protection Act, which is in fact a lot more stringent than the GDPR and than the CCPA, and is in fact something that people are currently using right now in court against Clearview. All of these laws give you the right to request that a company discloses or deletes any data it has collected on you, assuming, of course, you're a resident, which is, at the moment, the biggest, I would say, flaw and hole within privacy legislation, because there is no federal level privacy act that applies to things such as Clearview. It's very difficult for people to know where they stand, and they have to make do with various local and state privacy laws. A unifying theme among all these privacy legislations is the requirement of anonymizing any collected data. Not only must data be stripped entirely of identifying aspects, but re-identification must not be possible or encouraged. In my view, the de-identification requirement of privacy laws is the Achilles heel of facial recognition technology. Because as illustrated earlier, when you train a deep learning model to re-identify faces, you are inherently saving identifiable data on those faces. So even if you delete the original training images, the fact that you've retained the trained model means you've retained identifying aspects, because what good is a re-ID model that can't re-identify? For a more concrete example, when you make a CCPA request to Clearview, they send you an inventory of all the data they've collected on you. And if you request to delete your data, supposedly only those images that they initially sent will be deleted. What won't be deleted is a re-ID model that has already been trained on your face images. We know that because Clearview didn't share the vector embeddings or the re-ID model, so you can safely assume they didn't delete those. But as explained earlier, vector embeddings are just a numerical representation of an image. Even without the original image, Clearview still retains the ability to identify you, because in the same way you can generate a vector embedding from an image, you can generate an image from a vector embedding. So without a proper audit of Clearview's internal systems and code, it's difficult to know the extent to which they've retained and are still using re-ID data. However, researchers at Facebook have successfully developed a method of radioactive tagging, which can be used to secretly determine if a model has been trained on a specific set of images. So as you now understand, facial recognition is flawed by design. Ominously, those flaws are masked behind statements such as independently tested and 99% accuracy. While the technology itself is neither good nor bad nor neutral, law enforcement application deserves conscious scrutiny because it implicates important constitutional values. Indiscriminate use of facial recognition alters the traditional presumption of innocence by placing more of a burden on an individual to show that he or she is not who the system identifies him or her to be. Without proper safeguards, law enforcement use of facial recognition amounts to a backdoor repeal of due process. I introduced this talk with a short history of facial recognition. We'll end with a much longer history. A history that starts with the 121-year-old technology giant you've likely never heard of, NEC. Formerly known as the Nippon Electric Company, NEC has been servicing the US government with biometric technology since the late 90s. Broad market consumer facial recognition in the US dates back to 2004 with a company named PitPat, which was acquired by Google in 2011. Firms such as Tapwire, Terragant, Variant, Wolfcom, and Banjo have been in business with local, city, state, and federal law enforcement agencies for much longer than Clearview. What Clearview represents is a threat of legitimizing the unchecked infrastructural expansion of a powerful face surveillance technology. So the reality is our privacy is already endangered and has been dying for a very long time. Clearview is more the stench of corpses impossible to ignore, forcing us to address whether we want to bury it or if we want to burn it. For years, the ACLU and over 100 organizations in the US and worldwide have warned of the dangers facial recognition poses to vulnerable groups. In the beginning, arguments focused on accuracy. The response was more accuracy. As the technology has become easier to use, we are now seeing it being deployed on its most ardent supporters. So this is it, folks. I'd like to thank Todd, Jennifer, Danny Perez, and all the open source crew, and of course you, the community, for being here today. For those interested in downloading the code and data, you can feel free to visit my repository on GitHub. Like I mentioned, it has fully functional fully functional examples of the detection model, the REID models, some code you can play with, as well as raw footage that you can actually use to build something like this on your own. Again, thank you all for attending. I'm ready to take questions. I kind of skipped over the source code part, largely because I wasn't sure to what extent you guys wanted me to go into details. But if you have any questions as far as me going back and showing you some of the code, I can definitely do that now. Todd?
All right, Sam. Yep. All right. Tell you what, let's see. I'm going to turn my video back on. Okay. And obviously my audio is back on. So I just put a comment back in to the chat stream. Feel free to post questions and things like that. So Sam, I'll tell you what, why don't we, I'm not sure if you need your screen to maybe answer questions that if you,
I may. I have a few things queued up that I suspect you might ask me about.
Okay, very good. So let's see. I think here's what I'm going to do, Sam. Let's look first in the chat stream. I think that's where people are going right now. And if you can maybe take a look at the chat stream too. Peter DeVito just had a question. What's the confidence level on the request to the companies for data that they have collected? And if you maybe just want to start there and then kind of move backwards or move back up.
What's the timestamp for the question?
Oh, it was the most recent one that was posed from Peter. The
last one, 1241.
You know what? I'm not even seeing 1241. Yes.
1241.
Yeah.
What is going to solve? Gotcha. So that's the thing. Yeah. So this is kind of a how do I put this? Honor system thing. Yeah, honor system thing. You don't have any confidence at all that they're doing what they're supposed to be doing. In fact, one of the biggest arguments about the CCPA is the fact that it doesn't have any teeth. And even if a company was found to be in violation of the CCPA, you as an individual cannot sue them for damages until, of course, they get hacked and you realize that they never deleted your information like they say they did. And even if that happens, well, actually no, if that happens, you do have private right of action. But generally speaking, the only person under the CCPA that can actually go after a company for violating the law as is the State of California Attorney General. Now, New York City, I believe Washington State as well, are in the process of creating their own TCPA type laws. And I believe New York City is lined up to be probably the most aggressive law, because as you know, New York City is like litigation capital of the world, and in that privacy law, you have a private right of action. So if you wanted to go through the process of suing somebody under New York law, such that you are able to go through a discovery process to discover whether or not they have deleted your stuff, you can certainly do that, assuming, of course, the law gets passed. But with the CCPA, the GDPR, I don't really trust these companies that are doing what they're supposed to. I think especially companies like Clearview, because it's so difficult to verify that they've actually deleted your data. But generally speaking, the way you would test that is somehow get access to Clearview's application and try seeing to what extent it's able to recognize your face, which, as I mentioned, if they are retaining the same trained and re-ID model, it's going to be as efficient as it was with your data.
Okay, let's see. So that was, okay, so I think Mike Canada had a question regarding slides. So that's one that well, Sam, do you want to, how can people find your slides?
Oh, yeah, I will totally make this available. Do you, well, I guess, what do you post a video on YouTube or on a channel somewhere? Or
We do. What we're going to do, just everybody in attendance, as kind of an FYI, we are recording this now to the cloud. What we'll do is right after this wraps up, we'll download it, and then we'll begin the editing process. So we'll sort of cut it up into those two different versions that I had mentioned at the beginning of this meeting. We'll add an intro and an outro, and then we'll get it up on YouTube. So our goal is to get this talk and the talk recording up on YouTube, edited. Again, the full version from beginning to end, including my intro and then the outro, if you will, in addition to your talk, Sam. And then the second version will be just your talk. We'll try to get those up within about a day to 2 days. That's our goal. So we can make your slides available on SlideShare. So if you want to forward those slides to us, we'll get them up on our SlideShare account. And then in our post meetup communication, we'll share the slides and the link over to SlideShare, in addition to the link to the talk on our YouTube channel. Now, if you want to make those available, or encourage people to reach out to you in some other way, you're more than welcome to do that. That's not required in any way, shape, or form, but feel free.
Absolutely. In that case, I'll definitely give it to you, and you can put them in
Sure.
SlideShare.
Yeah, sounds good. Okay. Let's see, Colin Griffin. I know Colin well. Colin, thanks for joining. Let's see, Colin says, I may have missed it, but have you played around with WebAssembly for some of the client-side implementation? Excuse me.
I did not play around with WebAssembly. It's funny because I did full stack development for a while there, which involved obviously a lot of web application development. But recently I've just been focused so much on doing Python and backend stuff that I just kind of wanted to keep this as simple as possible. So using like a fairly simple stack ended up being the fastest way to implement this. But I have certainly considered, I've considered using WebAssembly for a lot of things, but this was not one of the projects I wanted to use on.
Okay, so let's move over to the Q&A feature. I believe that was, I think we've covered all the questions that was in chat, or that were put in the chat. So we're gonna, let's see this. I'm going to disable chat. I'm going to, okay, so, okay, so let's go back and take the first one. Well, actually, let's start at the end at 12:44. This comes from Nancy. Oh, sure. Nancy, was this recorded, and can it be viewed later? Where will we find the recorded link? Yeah, Nancy, I actually, I just answered that. So at the risk of repeating and boring you to death, we are recording this. We should have it edited down 2 versions. The complete version from the beginning of the meetup to the end will be available, and then just Sam's talk. If you want to save yourself a little bit of time and just view kind of the core talk, both those versions should be up within a day to 2 days. So we're moving as quickly as we can on that, and I promise that we will move fast. I'll contact everyone through Meetup, and then directly, and then we'll send out a link via social media as well. So we'll make you aware as soon as those are available. And Sam just stated that he'll forward his slides, and we'll make the link over to SlideShare available as well.
Cool.
Yeah, go ahead.
Yeah, I was gonna go up and.
Oh, please do. Sounds good.
So I suppose you could say that. I think generally with contract tracing, you're supposed to have, to a large extent, contact tracing is voluntary, right? As to you saying who you are. You might be the only one who knows your ID, but that ID gets like pulled into a centralized place. This is less so because this is more of a context where the vehicle is entering an area where it can be tracked, and that area is finite. And once it leaves that area, you have no idea where it goes. But as far as contact tracing goes, you can, for example, you can answer a question such as, were these 2 cars ever on FDR Drive at the same time? and so to some extent, you can say whether or not they came into contact with each other, but it's not as the definition of contact tracing that we are all aware of with regards to tracking spread of the pandemic or tracking spread of the virus is much broader than what we're showing here. But certainly, if you had enough coverage of an entire New York City, you can implement a contact tracing type of tracking or feature. How does the how does the US system compare to the UK and EU countries? I believe the UK has a pretty massive blanket of CCTVs across their entire, well, London, I believe. And to be, the EU countries, I'm not quite sure. I do know that EU is fairly paranoid about privacy, or at least Germany is anyways. And so I don't think they are as big into CCTVs and this kind of technology as the US and the UK are. But we know for a fact that I believe China is certainly the leader when it comes to this technology. There was an article that someone featured not long ago where it showed how quickly it was. So this reporter was kind of giving a demonstration of their system, and it showed how quickly that single individual was able to be found in a population of like several billion people. And so to that extent, I think as far as capability goes, the US certainly has the most advanced technology, but the only thing that's kind of like holding back the use of that technology is really legislation. The UK, I believe, is a little bit more okay with Big Brother kind of situations. The EU countries, again, it's on case-by-case basis, but for the most part, I feel like the infrastructure in a lot of the EU countries doesn't really make themselves available to these kinds of tracking situations, and especially given the history of a lot of these countries, especially countries that are like seriously involved in World War II, they are a lot more serious about privacy protection than the US and the UK are. Again, I think it's because like we've not actually experienced a completely tyrannical government yet. So yeah. So the blog post, so yeah, the blog post definitely goes into a lot more detail than my slides. I was kind of afraid of going over time, and so I took out a pretty large chunk that I now regret that I did, which was the chunk that talked about the process of running and scaling the object recognition piece of this on the AWS. But yeah, you can check out the blog post, and of course, if you have any questions, feel free to, like, about anything that I went through or went through too fast, feel free to ask, and I can follow up here. Are those drawings one I made? I don't know why somebody posted this. So yeah, I'm not sure I'm not quite sure which ones you're referring to, but I certainly made a few of the animations. I think I did like MS Paint a few of these things, but I didn't draw anything fancy. For the most part, I collected these from various sources online. Again, you can find the original pictures, or at least most of these original pictures, on my blog post, and the blog post itself contains link to the originals or link to the original articles. And you are very welcome, Nancy. So any more questions?
All right, Sam, let's see. I'm actually scanning the chat stream just to make sure. Let's see, good insight. You're very welcome, Grace. Thank you for joining us today. Let's see, we'll screensaver back as well. Okay, Sam, I'm not seeing any more. Any final comments or anything like that? And Sam, also, I want to thank you for being cognizant of time and very respectful of everyone's time. It's just super nice of you to do that. This is during lunchtime, so I know we have people joining us like on lunch break. That's one of the ways that we sort of promote this, right? Kind of the value proposition, at least one of them is that if you're working and if you're going to be eating, as long as we're all remote, you can do that. And you can actually take in some good education and some networking as you're eating, or maybe as you're taking a break during the workday. So, the fact that gosh, you were right on time. I mean, you wrapped up right on time, and the questions and everything like that allows everybody to kind of resume their day on time, and you're not taking people over. So I definitely want to thank you for that. Extremely mindful and thoughtful. Thank you. Any final comments or anything like that?
No, I just want to say again, thank you everyone for attending. It was kind of a lot of fun working on this application. when Clearview came out, it was a pretty big deal, and to some extent, the pandemic has kind of drowned out this. But this is a big deal, and from what I'm seeing, legislators are taking it seriously, and I hope once things start to get back to normal, people are able to take a look at what they're effectively losing, and start taking this kind of technology and Clearview more seriously.
Yeah, Sam, I would completely agree with you. And again, just to kind of go back to what my introductory comments were, we felt like, Clearview was something, again, it really got our attention. This has been going on a while. This is prevalent in other countries, as you stated, but it is something that's definitely on our radar screen. I think people should, the first step in taking any sort of action that you might choose to take, either for yourself or on behalf of others, is awareness. Very difficult to do that intelligently if you're just not aware, if you simply don't know. So we're all about transparency. We're all about education and heightening awareness. So it's something that we really wanted to do. So again, thank you again, this is a presentation that I was sitting here, with rapt attention, watching as you were doing it, because it's in my best interest to learn as much about this as possible. So thank you. Okay, so here's what I'll do. I will go ahead and wrap us up with just a few final announcements. I got about 12:55, so I'm going to do this in maybe two minutes or so, and try to get us out, quote unquote, by 1. Again, for those of you that weren't able to join us at All Things Open 2020, things went extremely well. We had about 7,500 people that registered, and almost that many people that joined us from around the world. Anytime you have people register and then participate, there's always a little bit of a gap there. There's a little bit of a delta because not everyone that registers actually signs on and participates. So, but this time almost everybody did, not quite, but almost everyone. So overall, ATO 2020 went extremely well. Please save the date for 2021, October the 17th through the 19th. So go ahead and get that on your calendar for ATO. We do anticipate there being an in-person element to this. And a virtual element as well. So again, hopefully a number of you can join us in downtown Raleigh at the Convention Center. Hopefully the vaccine will have been distributed and people will feel comfortable and some of the restrictions will have been lifted before October the 17th of next year. We feel like they will be. How many and to what extent, we don't know. A lot of that is to be determined, obviously, but our fingers are crossed for sure. So we hope that you can join us. Spacewalk is the annual kickoff the new year event that we do every year. We're going to do that. Again, that is scheduled for January 19th. And as of right now, it's a virtual event. We'll probably be on site at a theater, kind of broadcasting live. And then maybe a few people will be there watching, but there won't be very many people at all. Again, safety is our first priority always. We did do a giveaway here in the chat stream a little ways back. I think I posted the link that you can sign up to try to win some of the giveaways that we're doing today. I think I posted that twice. So anyway, feel free to submit your interest and we're going to go ahead and choose winners and notify you. We'll do that a little bit later today. We are giving away Raspberry Pi kits, which are pretty cool. The Donald Knuth Art of Computer Programming four box, kind of the 4-set series. Actually, it's a series, really nice 4 books within the set. And that would look great on a bookshelf. That's about a $200 or $250 value. And then we're going to give away some shirts and hats, of course. So anyway, feel free to do that. Sam, thank you again. I've got just before 1 o'clock, so I always want to be mindful of everyone's time. Thank you all for joining us. We've got some big things in store for 2021. Again, COVID is still impacting everything. So we're in kind of a wait and see pattern along with everybody else. But in the meantime, and even though we are somewhat in that holding pattern, waiting to see what's going to happen, we are putting some really cool things together that we're going to roll out in 2021, regardless of what happens with COVID. So anyway, please be on the lookout for that. Hope everyone has a great holiday. This is our last official event for 2020. Again, we're going to come back strong with Spacewalk on January the 19th. But I hope everybody has a great holiday season. Please stay safe. At the end of the day, after all this is said and done, after we get a little further down the road, all that's really going to matter, friends and family, your experiences and things like that. So obviously we need to, we all need to be as safe as we possibly can. I know this has been such a unique year, but please stay safe and we look forward to seeing you next year.